Hello, today we're going to be looking at probabilities from tables. So we're going to find the normal probabilities when they don't land exactly at certain standard deviations. Now here's the standard normal table. Your z-score is on the left-hand side, and if it goes past the one decimal place, you go over here. Now each of these percentages or probabilities is the probability that's at or below. For instance, if I want to find the probability that my z-score is less than negative 3.1, I go to negative 3.1, I look at the value right next to it, and that value is 0.0010. Now, it gets a little trickier here when I want to find the probability that my z-score is greater than negative zero point 0.4. Negative zero point 0.4 is here. Now, that's just the values that are at or below negative zero point 0.4. So if my z-score is 0 is here, negative zero point 0.4, this represents this side. But this is asking for the other side over here. So what we're going to have to do is we're going to have to take our value, which is 1 minus 0.3446. It's not very legible, but 1 minus 0.3446. And that's going to get us to 0.6554. So about 65%. All right, let's try some more. Now, the other one had negatives. Here's another table with z-scores that are positives. So if I want to find the probability my z-score is greater than 2.53, 2.5 is here. 0, 1, 2, 3. Oops. And we know that 0.9943 is at or below. So now we just have to do 1 minus 0.9943 to get 0.0057. Now there's another one. Probability is 0.59 is there's z-scores between 0.59 and 1.24. 0.59 is going to be over here. 1.24 is going to be right here, 0.8925. So this is a little tricky to explain, but if I look at my normal distribution, especially since my cursor's not working very well, 0.59 is probably here. 1.424 is probably here. So if I want to go to the left here, that's 0.7224. But if I want to go from here to here to the left, that's 0.8925. So if I want to find out what's in between those, I have to subtract them. 0.8925 minus 0.7224, I'll get 0.1701. And so that's how I find my value in between. So now, what happens if the z-scores are smaller or larger than that? Well, if they're larger than 3.4, it's going to be almost all of the data, 0.9999. And if it's less than that, it's going to be almost nothing. It's 0.0000 something. Now here, let's do a problem. 14-year-old boys have a cholesterol with a mean of 170 and standard deviation of 30. Now we want to find the percent of 14-year-old boys who have a cholesterol over 240. Now part of this is learning how to write this so AP loves it and accepts it. The first thing we want to do is write what we found. We want to find the probability that our value is above 240. So we want to find the probability that our x is above 240. Now once we have that, we want to convert it to z-scores because our standard normal is in z's. So to do that, I subtract the mean and divide by the standard deviation. Once I have that, I can just do the math, and I have 2.33. And then now I go to the chart. If I have 2.33, I go to the chart, that's negatives, 2.33, 0, 1, 2, 3. That's 0.9901. Now I'll just take 1 minus that, 1 minus 0.9901. 0.9901, I apologize. And I'll get 0.009 for an answer. So 0.009 is the probability it'll be over 240. Now if we look at what's the difference between, so 0.009 is this part out here, but if we want to see what's the difference between equal to or not equal to, hopefully you know that should be, there is no difference, because in a continuous random variable, being equal has a probability of 0. Now what percent of the values of 14-year-old boys have a cholesterol level between 200 and 220? How AP would love us to write this out would say, what's the probability our x values between 200 and 220? Then we would find a z-score for each of those values, which when we divide it out is between -1 and 1.67. So now once we have that, now we do the same thing we did before, and hopefully you find it, oops, 0.79. All right, so that's the end of our video. Good luck.